My name is Bob Sutor. I'm the Vice President at IBM Quantum for Ecosystem Development, and today we're going to talk about quantum computing on the cloud in the 21st century. Let's begin by looking at this word quantum. It seems to be somewhat a mysterious word for many people and leads to a lot of what I'll call creative thoughts. A lot of movies have the word quantum in them, television shows too. Quantum of Solace, the James Bond movie. Quantum Leap, well, that was a TV show when I was much younger. Quantum Apocalypse, Quantum Vengeance, and perhaps in a more lighter vein, Quantum Love, Quantum Master, Quantum Yoga, and Quantum Guitar Complete. I mean, what else would you want there? And there are many books, and this is not talking about the books about physics and computation that really involve quantum. The Quantum Spy, Quantum Assault, the Quantum Magician, Quantum Flare. Moving away from fiction, perhaps, quantum leadership, quantum psychology, quantum spirituality, and once again, and not related to the movie, quantum love. Well, there are other products as well that use this word but are not really quantum. If you look around the web, if you look in your local market, you can see dishwashing detergent or kitchen sinks, leather and fabric sealants, sports cars, bicycles, vitamins, ant control bait, and I would say quantum inspired anything. Because if they really were quantum, they wouldn't say they were quantum inspired. So all of these things make use of the word quantum for marketing, even though they are not really quantum. And when I see these, my first response is typically, WTQ? Well, what's going on here? This isn't quantum as I know it, at least. Well, at IBM Quantum, we're working on real problems, problems that are important to our clients and our partners. And we're doing it with real, authentic quantum hardware, not just simulations of that quantum hardware. And you'll see how many we have, and in fact, how many people are using it as well. Now, the progress we are making on the hardware, on the software, on the systems is driven by partnership and relevance. And we'll see in a little bit about the IBM Q network, the different people who are coming together to get us to the point where quantum computing can do better than classical computing alone. So what are some of the examples? What are some of the areas in which people are looking? Well, the first is chemistry, and this is simulation of physical processes. That's the general category. So things like molecular modeling, trying to get more efficient lithium batteries, material science, eventually, not in the very short term, because we're going to need very large quantum computers, things like new medicines, right, for healthcare. The second area is financial services simulations. So this is using real quantum hardware, but for financial services simulations. Well, these simulations, such as doing risk analysis or pricing, we want them for larger portfolios. We maybe want them to be more accurate. We want them faster, and we want them to be less expensive. Now, these are frequently optimization problems. So even though I've cast this as financial services applications, these techniques are expected to be used even more broadly in many other industries as well. And then my third example is finding better patterns for artificial intelligence and machine learning. So there are really two sides to this. Can we use quantum computers to do the math better for AI? Or, in fact, are the properties of the quantum computing model, such as entanglement, such that we can use them, and remember they have no classical counterpart, to find patterns in better ways, or in fact, patterns that just would not emerge from classical methods. So we are hopeful that we can use quantum computing for machine learning, for deep learning, but we also think that those techniques like neural networks will also help us do quantum computing even better, and then we can apply them to areas such as chemistry. we're on the road to quantum advantage. Quantum advantage is the point where a quantum computing system, and that consists of quantum computers plus classical systems, can do better than classical systems alone. Now that's important to understand. We don't talk about a hybrid because a quantum computing system must include classical systems. It's just the way it is. And the type of improvement we're looking for is not just twice as good or 3 times as good. We want improvements that perhaps are something like the square root of the amount of time it previously took. That's a quadratic improvement. So this is what I mean by a significant type of improvement. Now, the quantum science that underlies all of this started in the early 1900s. We are now in the quantum ready phase. We are building those systems. We are getting more people to use them. We are identifying use cases. And all in all, we're getting ready. We're educating ourselves to move what we hope to in mid-decade to this point of quantum advantage. Now, here's another way of looking at it, using a modification of the traditional crossing the chasm curve. So I think so far we have been in this innovators phase. Now, the chasm here is the eventual quantum advantage, after which we will see return on investment, right, and the significant improvement I mentioned. But there are really 2 phases before this chasm, before quantum advantage. I believe we are now moving to the early adopter phase. These are new people, new businesses that are looking around and saying, hey, some of my competitors are starting to get involved with this quantum stuff. They're identifying use cases. They're working with vendors like IBM to see how this will give them that advantage. So it's going to be a very interesting phase with a lot of new people getting involved, and we have to work with them very closely. The education is going to be a little different, and their concerns are going to be different as well. But this is where I feel we are in market evolution. Now, another type of evolution is how far we have come on the cloud. To listen to some, you would think that quantum on cloud is this brand new idea they thought of 3 months ago. In fact, we are now in our 5th year of having quantum computers on the cloud. We at IBM Quantum first put a 5-qubit quantum computer on the cloud on May 4th, 2016. That's a long time ago. Here's a photo of Jay Gambetta with an iPad showing using the composer to create a circuit that was running on the cloud way back in 2016. So now we're going to start with the assumption that quantum on the cloud is not new and has been evolving for quite some time. So where are we really? I've already touched on the use cases that people have been looking at, but let's take a look at some numbers. 4 years after launch, we have nearly 250,000 registered users. So if you think that perhaps no one's using quantum computing, well, you're forgetting about 250,000 people. Now, these people have run over 240 billion quantum circuits on real, authentic hardware. Coincidentally, those 2 numbers are similar, but that's a lot of circuits. So a circuit is the basic unit of work or of computation for quantum computing. Over 240 billion of those. That's not on day one. That's a lot of work. That's a lot of evolution. That's getting your cloud to support 18 quantum computing systems. So the progress has been terrific so far. Now, your gateway to this is the IBM Quantum Experience. This is how you use quantum on the cloud. You can get in and you can be using IBM Quantum within just a very few minutes. You register, you go in, and you can start experimenting. Now, for some people, because their entry point to quantum may have been through textbooks, they're familiar with traditional circuit diagrams. For those people, they may want to start with the composer, and you see this in the lower left. It's a drag and drop environment. You create your circuit, and you can run it, right? You can choose where you want to run it, and away you go. Now, for other people, they're more interested at, let me say, a different level, at the algorithmic level, at the coding level. So I want you to think of this, that we are building circuits from the ground up, but we're consuming them in an easy-to-use way from the top down. So at the top level, there are algorithms. Then we drop down to quantum circuits. Those, we're getting closer to the hardware now, are quantum operations. And with IBM Quantum, in fact, you can get to the pulse level. This is direct control of the hardware. So if you're a researcher, if you're a scientist, if you're an engineer, and you want to create highly optimized operations on our quantum computers, we give you access to that. This is not simulation. This is the most advanced use possible of the best hardware available today. So this is through IBM Quantum and through QuizKit. QuizKit is the open source quantum computing software development library. It's Apache licensed. It has been out for several years. And we've been enhancing this with the circuit library. And this is a way of making it much easier to use circuits. So here, you pretty much just want to say, I want you to do this. And then you would like optimized circuits to go and do this. So it's a way of designing the library. You can use it at a very high level, QuizKit Aqua, or with Pulse, you can get to a very low level and everything in between, because the quantum ecosystem is very large now. We have people who want to operate at a high level and people who want to operate at a very low level, and we need all of them. And that's what IBM Quantum plus QuizKit provides. Now, as an example of this, I want to specifically point out the optimization library. When you're interested in doing an optimization, you want the answer. You want the best algorithms. You want it to run on the appropriate hardware to get to your answer. So you're not thinking, oh, hybrid and all this type of thing. You're thinking about getting an answer. So we have been working very hard to merge these concepts of what you would do classically with software like CPLEX and what you can do with a quantum computer. So this is putting us on a single track to solve optimization problems that are useful for industry and many other organizations, governments, in many different contexts. Now, I want to give you one more idea of people using these systems. In early May, we ran a challenge. We put up 4 problems. First one was relatively straightforward. The last one was pretty tricky. It wasn't easy at all. In fact, 4 people in the world got a better answer than we thought they would be able to get. So participants from 45 countries, 1,745 people, 574 did all of them correct. Think of that. Think of the over 500 people who did some really hard problems in quantum computing using real quantum hardware. Quantum talent is there, and it is increasing, and they're doing it through IBM Quantum. Now, these people did something else that was very special. Together with our usual clients and partners, they helped us run over 1 billion hardware circuits per day over 4 days. Now, that is historic. Real quantum hardware, not simulators. Over 1 billion circuits a day. And they're only using it more and more and more. Now, to conclude this, I've talked about partners, I've talked about clients. Let's get a little bit more detailed. This is the IBM Q network. These are people coming together to get us to quantum advantage as quickly as possible, to accelerate research, to eventually develop commercial applications in this quantum ready phase, to educate and prepare. And once again, the numbers are really quite big. Right now, in the middle of June 2020, In the IBM Q network, we have 113 members, partners, JP Morgan Chase, ExxonMobil, Samsung, Daimler, JSR Corporation, Accenture, Goldman Sachs, Woodside Energy, BP, Amgen, and Boeing. That's quite a range of industries. Hubs, which are centers of excellence for quantum research themselves, and they work with other organizations, which may be companies or government labs. They're not just in the United States. Members from around the world, dozens of startups, dozens of academic institutions, which are important for their research as well as for education. So I think I've given you a lot of evidence here that quantum on the cloud is not new. Quantum on the cloud is well advanced, as demonstrated by the IBM Quantum program. We have by far more users than anyone else. Through QuizKit, we have by far the most widely used open source development platform for quantum. And it's based on Python, which, oh, by the way, 8 million developers use as well. So all the signs are pointing now to a rapid expansion of work on quantum computing, from the science to the engineering to quantum software developers, quantum software engineers, to people examining the business use cases, to educators, right? In universities, but also as low as high school. Many people are learning this, and they're learning how it fits together with classical computing to create a brand new type of computing. So really, as we look at all of this, I think there's just one more question, which is, have you accessed IBM Quantum on the IBM Cloud today? It's not hard to do. It'll just take you a few minutes. You can use the composer, you can drag and drop, you can take your textbook, you can build circuits, or you can code. There are dozens of Jupyter notebooks that are available. If you care to and you want to go back and see what people did in the IBM Challenge, we have notebooks for that as well. So there's really nothing stopping you. We have made this as easy to use as possible. So I encourage you, get started with Quantum on the cloud today. Specifically, if you want to go with the worldwide leader, the most advanced program with the largest community, open source, go with IBM Quantum plus QuizKit. Thank you very much.